Database updates and deletes with Entity Framework Core have been traditionally a bit inefficient because you were forced to first find the relevant entity and only then you could request the update or delete from the database. However, Entity Framework Core 7 introduced a couple of new powerful APIs that finally allow you to perform these operations in a very efficient way. So today I'm going to show you the new way to perform database updates and deletes with Entity Framework Core. Let's start. To demonstrate the new way to perform updates and deletes with Entity Framework Core, I have prepared a very simple web API project where the idea is to manage a super simple list of games. And before going through the code, just keep in mind that the new APIs that I'll show you require using at least version 7 of Entity Framework Core, which of course comes with the .NET 7 SDK. So let's start by going through the code that I have already just to understand better what this API is about. So I'm going to open up program.cs here, which is known as the entry point of the application. And I'm going to collapse this for a moment. And what we're going to notice is that what we have here is 3 endpoints that are used to manage a list of games. The first endpoint over here is used to get the full list of games from the database, which by the way, the database is a SQL Server database. And then we also have an endpoint for performing updates via the put verb over there. And then we have an endpoint for deletes. Now, as you can see, both delete and put are not implemented yet. We're going to be implementing those in this video. But we do have an implementation for get already. And as you can see, we're going to be listening in the /games route. And you're going to notice that we're receiving an instance of this GameStore context class. So if you know Entity Framework, you know that GameStore context is really an instance of a DB context, and that is the object that you can use to interact with your database without having to write any T-SQL, right? Now this GameStore context is getting injected into our method over here. So it's using the dependency injection mechanism, and it's actually registered a few lines above. If you see here, close to the top, we invoke the add SQL Server method here to add the GameStore context, right? An instance of GameStore context into the service container so that later on it can be injected into any other method. As you can see, we're injecting that in get, in put, and in delete. Now, let's take a look at that GameStore context very quickly. So I'm going to open up my Explorer over here. So that is defined in my data directory over here, GameStore context. And so as you can see, it's super simple. All it is a class that inherits from DB context, and it defines just a simple DB set of type game, which is the entity we're going to be managing. And the game is defined over here in my entities directory. Super simple. It only has an ID, a name, a price, and a release date. And I have already performed the migrations and applied the migrations for this into my local SQL Server database. So the mapping between this model and the corresponding games table has already been performed. Okay, now going back to my program.cs, and I'm going to collapse this and this. So what we can do first is to actually exercise this API to see how it's working. So what I'm going to do is just to open my terminal here. So open that, Ctrl J, and then I'll just do .NET run. Okay, so it is up and running. And then in order to test this API, what we're going to be using is an extension to VS Code that is known as the REST client, which allows us to create a little file that we can use to invoke the REST API directly from VS Code. Now that extension, let me show you very quickly. If we open the extensions view, that extension is known as REST client. REST client is this one here by Wanchao Mao. So you can go ahead and install it. It's free, and it is a very, very cool extension. Let me show you how to use it. So I'll close this and I'll open up my Explorer view once again. So I'm going to be opening this file named games.http over here that I prepared. And let me collapse this for a moment. What this allows us to do is to just define in very simple terms how to invoke the different endpoints of the REST API. As you can see, this is going to be a get call, the first line, a get call. And here is the location of our server. If we open up the terminal, we're going to see that that is in fact the location of our server right there. And so it's just going to invoke the game's endpoint that we already defined, right? And I have already defined other invocations for both put and delete over here that we're going to complete in a moment. And so let me open terminal again. And if you go ahead and just click on send requests over here, there, you're going to see on the right side, we get our list of current games, right? So right there, we have 3 games already defined in there. And the whole point of our current exercise is to figure out a way to be able to both update or delete either of these games using Entity Framework Core, right? And so let me close this and let me also stop my server now. So let's go back into our program.cs file over here. Okay, so collapse this and this. So let's focus now and let's start with the update operation. So the put endpoint over here. So the first thing we're going to do is just to look at the traditional way to perform an update operation, and later we're going to be looking at the new way that you can do this, right? So usually what you do for an update is first you want to fetch the game to update, right? So let's say this is going to be var existing game, okay, equals await, okay, it's going to be context dot games dot find async. And then we're going to be passing the ID of the game to find, right? Which we're receiving from the parameter over there. Now, since we're going to be using the await keyword over here, we also have to specify that this is going to be an async method there. Okay, so then we found the game, and then of course, once we found it, what we want to do is go ahead and update the properties, right? So in this case, we will be doing existing game dot name equals updated game dot name, and then we have existing game dot price equals updated game dot price, and finally we have existing game dot release date is the updated game dot release date. Now, of course, we're getting a little bit of a warning over here, as you can see, because the compiler is warning us as saying, hey, this existing game could be null, which in fact could happen if, for any reason, find async is not able to find the game, right? For instance, if the client provided an invalid ID, right? So existing game could be null. That's a warning that we have here. So how to solve that? Well, one way to do that would be to actually just check for nullability there and return a specific result in that case. So for instance, we can say if existing game is null, we can go ahead and return something that's kind of appropriate for that situation, which would be results.notFound, right? So we could not find it, and then just by doing that, the compiler knows that existing game at this line 26, it has to exist, right? So the warning is gone. Now moving on, after we do all of those updates, since Entity Framework is keeping track of all the changes that we make to the existing game object, all we have to do now is just say await context.save changes async, right? And that will go ahead and send the query into SQL Server to perform the related updates, right? And then finally, likely we want to do something like return results.noContent, right? Which is the typical response for an update operation. So this is kind of how you could implement a put operation. There are other ways to define a put RESTful endpoint, but this should work just fine for this example. So let's see how this works, right? So let me go ahead and open up my terminal once again, and I'm going to start the application. Let me actually clean this a bit before doing that. There you go. So let's start this, and let's go back into that games.http file that we looked a moment ago over here. And as you can see, and let me collapse this for a moment, we do have defined here a body for a put request. So let's figure out what game we're going to be updating here. So let me send a request for the get first. So send request. Here we have our get once again. Let's collapse this for a moment. And let's say we're going to be updating the first game, Street Fighter 2, right? Let's say that we want to change the price because it is on sale, right? So let's go ahead and try updating that one. So I'm going to just copy the body of Street Fighter 2 over there, and I'm going to paste it over here. This is going to be the body of our update, and I don't think we need to specify a time here. The date will be good enough, but what we want to change is the price, right? Instead of being $19.99, let's say this is going to go down into $9.97, right? Which is a very good deal. So yeah, so that's going to do the update. So let me open up my terminal once again, so we can see what happens behind the scenes. And so scroll down a little bit, and now let's go ahead and of course we're missing just one more thing, which is the actual identifier of the game update. So I'm going to put number 1 here because we want to do a put into the game number 1 with this brand new body, right? So that we replace the element. And so let's click on send request, and as you can see, we did get the expected no content result, which means that this was successful, right? But more interestingly, let's look at what happens in the console over here. So notice that for making this happen, we had to execute not one, but 2 queries into SQL Server, right? First one, if you can see here, this first query over here is the one that was used to first retrieve the item to update from SQL Server, right? And then after doing that, we moved into the second query, which is this one over here, which is the one that actually goes ahead and updates, in this case, the price based for the specific item that we are, or game that we are updating, right? So that is one of the reasons why things are not as efficient as they could be, because we need to do this whole round trip of first retrieving the item and then sending a subsequent request to SQL Server to perform the update. All right, so, and that's a case of update. And then let's go ahead and now switch to our delete operation, right? Let's see what happens with delete. And let's do a very simple implementation of a delete, which once again is going to be very similar to the one that we have for update. So I'm going to just copy these few lines over here. Okay, so let's go down into delete and let's paste that. Okay, same idea, and we have to specify that this is going to be async, of course. And so we go ahead, we need to find the game to delete. We need to check if it is null or not. And then we can say context.games.remove existing game, right? Because sadly here there's no way to say, hey, I want to just remove whatever game has ID, the ID that comes the parameter. You do need to find the game first, and then you have to invoke the remove method. And finally, you can invoke await context that save changes async, like that. And of course, at the end, we will return results that no content, right? So this is one of those things that really I never really like too much. I mean, the fact that you need the entire object to perform a removal. And this is because by doing this, what you're doing is asking Entity Framework to keep track of the fact that this entity is deleted. And then when you invoke this line here, it should send that delete request into SQL Server. Okay, so let's now look also how this works. So let me open my terminal once again. I'm going to clean this and I'll do .NET run. And then let's go back to games.http. And once again, let's query first the list of games. Once again, I'll just click here so that we can get the list of games on the right side. Okay, and so let's choose one game to delete. So let's say that we're going to be deleting the second one, Final Fantasy XIV over there. And so on the left side, I have prepared this delete request, where all we have to do in this case really is just put the number 2 right there. Okay, and then we should be able to perform the delete. So I'm going to click on send request. And as you can see, this was successful, 204 no content. Okay, but once again, notice what happens on the SQL Server side, right? So first we had to do this request, this query over here, to find the game that was going to be deleted, right? And only after that, we can go ahead and do the actual thing that we wanted to do, which is to perform the delete operation, as you can see here. Okay, so once again, an entire round trip just to perform a delete of this one game. Okay, so this is the kind of stuff that makes things very inefficient, and that, I mean, that's what's the original case so far. But of course, there is a brand new way to do this these days, and starting with Entity Framework Core 7. So let's stop this and let's look at that new way to do things. So let's see how can we improve this overall. So let's go back into our update case, or our put endpoint over there. So instead of doing this, what we can do is to take advantage of a new feature and a couple of new APIs, which are known in the case of update as bulk updates, right? And also bulk deletes for the case of delete. So how to do that? So let me actually remove all of this because we're not going to be using any of that anymore. And what we want to do is the following. So we're going to be saying await context.games.where. Okay, so we're going to be using this where here first to identify what is the item that we want to update into the database. So we're going to just say, so the game where game.id matches the ID that we receive as the parameter. So that defines a filter. And then what you want to do is to invoke .execute update async, this brand new method, execute update async, which is the one that you can use to define which properties are going to be updated, or which columns are going to be updated in the table, and with which values, right? So in this one, you want to receive an object, let's call it just updates, okay? And then this is going to be another arrow function. So let's go into our next line. And then via this updates object, we're going to be able to set each of the properties that we want to update. So we're going to say updates.setProperty. And in this one, we're going to be receiving our game object over here, and we're going to be able to say game.name is going to be updated via updatedGame.name. And then I'm going to close our column there. And just like we do that, we can do the same thing for every single subsequent property. So let me just copy this. And then in the next line, I'm going to be doing this and then this again. Let's align this a little bit better. And so for the second one, we're going to be saying game.price is going to be using updatedGame.price. And then finally, game.release date is going to be updated game.release date. Okay, so once again, the first line defines the filter of which game is going to be updated. And then this execute update async method executes a batch update with all of the updates that are going to be performed via what was found via that filter is going to be set with the properties that are defined over here. So each of the properties are going to be using the brand new value that is coming in this updated game object over there. And the cool thing is that by executing this, there's not going to be any change tracking or any need to first retrieve the item from the database to after that send it back via the change tracking, right? This is just one call that goes straight into the database. And then just to complete our REST API and provide a meaningful result, what we can do is also capture the result of this operation here, because it's going to return the number of rows that got updated, right? So if I just say, let's say var rows affected equals, then the result of that, right? So now we can go down over here and we can say the following. We can say return rows affected. If this was 0, right? If it was 0, it means that it was actually not able to find the game that should have been updated. So in that case, what we can say is, okay, so results dot not found, all right? And then otherwise, it means that yes, we got some rows updated, so we can return results dot no content. Okay, and so that is how you can perform a database update using the new APIs from Entity Framework Core 7. So let's see how this actually works. So let me go and open up my terminal once again, and I'm going to clean this. And then let's do .NET Run. And then let's head back into games.http. And then once again, we're going to go ahead and perform a put operation, right? So let's first just retrieve things. So let's retrieve this. Let's see what's the current status of things. And as you can see, we still have our 3 games, right? Street Fighter, well, in this case, 2 games because we deleted one, of course, but we still have Street Fighter 2 over there. So let's say that we want to bump the price again because the sale is over. And in fact, it's going to be more expensive now. So it's going to be $29.99. Okay, that's going to be the updated price. And so let's go ahead and execute this. So let's say send request. And as you can see, this time there was only one invocation into SQL Server, which is right here. Here's the command. That in this case, it looks different because what it's doing now, it is using a filter. The filter is in the last row over here, filters by ID, and they will go ahead and update the table using the specific properties that we specified, as you can see. So there is no need anymore to go ahead and first retrieve the items and then send back the updates. The command that you see before over here is not really related to the update. It's just the one that we executed initially when we retrieved all the items a moment ago. Okay. And so that is what makes this super efficient, right? There's no need for round trip anymore. Okay. And so, yeah, and just like we did this, we can go ahead and do something similar for our delete operation. So let's go down here and things are going to be fairly similar. So what I'm going to do is the following. So let me copy this first line from the put down here. And so I'll replace all of this with just this line, because this is going to once again define the filter of what is going to be the game that needs to be deleted. And so after that line, all you have to do now is just say dot execute delete async. All right. So that is going to go ahead and delete any game from the table, SQL Server table, that matches the filter that we have defined over here. All right. And just like we did before, we can return once again based on the rows affected. I'm going to copy this. Based on the rows affected, we can go ahead and return either not found if we cannot find the game to delete, or a no content if we were able to find the game and deleted it. Okay, so let's test that out. So I'm going to open my terminal once again, .NET Run, and let's go back into games.http. Once again, let's retrieve all of our games. Let's see what we have so far. Let's retrieve that right here on the right side. Right now we have 2 games. So let's say that this time we're going to be deleting FIFA 23, which has ID number 3. So let's scroll down into our delete request. So let's replace 2 with 3 right there. And let's execute the request. So I'll do send request. And once again, notice that, this was a success. So no content, that's great. But more than that, down here, you can see that we only have one query down here to be able to send the delete operation into SQL Server by filtering by the ID that was specified. So there was no need to first query SQL Server for the item and then go ahead and perform the deletion. Right? So yeah, so let me collapse this, close this and that. Let's go back here. And so yeah, so that's what I wanted to show you today. I think it's a very nice new feature of Entity Framework Core, and I think that this is definitely the right way to start performing our updates and deletes into SQL Server via Entity Framework Core. I hope that was useful, and if you'd like to know more about Entity Framework Core and minimal APIs, please check out my site for complete courses where I cover that and many other topics that are essential for professional .NET backend developers. Consider liking this video if you found it useful, and don't forget to subscribe to the channel so that you're the first to know whenever I publish new videos. Thanks for watching and see you next time!